We live on a small, blue planet orbiting an average star in a galaxy filled with billions of other stars, each surrounded by its own array of planets. But when we look out into the cosmos, a question emerges: are we truly alone? Or are there other worlds, distant and strange, where life thrives in forms we can't even imagine? The search for life beyond Earth has captivated humanity for centuries. From ancient philosophers gazing at the stars to modern-day scientists peering through powerful telescopes, the question has always been the same: are we alone? And now, as technology advances and our understanding of the universe deepens, we're closer than ever to answering that question. The discovery of exoplanets, planets that orbit stars outside our solar system, has transformed our search. No longer confined to our own solar neighborhood, we've now identified thousands of exoplanets in distant star systems, many of which may share key characteristics with Earth. Some of these planets reside in what scientists call the habitable zone, the sweet spot where temperatures are just right for liquid water to exist, a vital ingredient for life. The question is now, could these faraway worlds harbor life? Could they hold the secrets to understanding life's existence across the universe? To answer that, we need to explore the very nature of life itself and what conditions must exist for it to emerge and thrive. Before we can look for life, we must first understand what an exoplanet is. An exoplanet is simply a planet that orbits a star other than our Sun. They can vary widely. Some are rocky, like Earth, while others are gas giants, similar to Jupiter. Some might even be composed of ice, or exist in exotic systems with multiple stars. Scientists detect exoplanets using a variety of techniques. One of the most common methods is the transit method, which involves observing the dimming of a star's light as a planet passes in front of it. This allows astronomers to determine a planet's size, its orbit, and sometimes even its composition. In the last few decades, this method alone has led to the discovery of thousands of exoplanets, some of which could potentially harbor life. But what makes a planet capable of supporting life? Life as we know it requires a very specific set of conditions: temperatures that allow liquid water to exist, an atmosphere that can provide protection and regulate temperature, and the right mix of chemical elements that can form the complex molecules necessary for life. In short, the conditions must be just right. Water is essential because it acts as a solvent, facilitating chemical reactions that form the building blocks of life. In the right conditions, water allows molecules to interact in ways that are crucial to the development of life. But it's not just water we need. A planet must have a stable temperature range that allows water to remain liquid, not too hot to boil away or too cold to freeze. On Earth, our atmosphere plays a critical role in maintaining these conditions. The gases that make up our atmosphere help regulate the planet's temperature, trapping just the right amount of heat while keeping harmful radiation from the sun at bay. Venus, despite its similar size to Earth, has an atmosphere so thick and toxic that it creates a runaway greenhouse effect, causing surface temperatures that would melt lead. It's clear, having the right kind of atmosphere is vital. If a planet's atmosphere is too thin, it can't trap enough heat, causing the surface to be too cold for life. But if it's too thick, it can lead to dangerous temperatures, as Venus demonstrates. The key is balance, just like Earth's protective blanket of nitrogen and oxygen. So, what happens when we find a planet with water, a stable atmosphere, and the right conditions? How do we know whether it harbors life? The answer lies in the detection of biosignatures, chemical markers that might indicate biological activity. Biosignatures can be gases like oxygen, methane, or nitrous oxide. On Earth, These gases are produced by living organisms, plants, animals, and microorganisms. In large enough quantities, these gases could indicate that a planet's atmosphere is being shaped by life. But detecting these gases alone isn't enough. Certain geological processes, like volcanic activity, can also release gases like methane or carbon dioxide. So, scientists must look for a combination of gases and their relative abundance to determine whether life is at work. Oxygen and methane together, for instance, are especially interesting because they don't naturally coexist in large amounts without a source of life to replenish them. Using powerful telescopes like the James Webb Space Telescope, astronomers are able to study the atmospheres of exoplanets in greater detail. This allows us to detect even faint biosignatures, potentially signaling life in the most distant reaches of the universe. But the search for life is more complex than simply looking for Earth-like conditions. What if life exists in forms we can't even imagine? Earth-based life is carbon-based and depends on water as a solvent. But scientists have speculated that life could exist in radically different environments, where chemistry operates in unexpected ways. Some have proposed life forms based on silicon instead of carbon, or organisms that use ammonia rather than water. Perhaps life could thrive in the frozen oceans beneath the icy surfaces of moons like Europa or Enceladus. In these alien oceans, life might not look anything like what we know on Earth. It might not even need sunlight to survive. Chemicals from hydrothermal vents could provide the energy for life to flourish, just as they do in Earth's deep-sea ecosystems. These hidden underwater worlds could harbor microbial life, or even more complex organisms, adapted to extreme cold and high pressure. The possibilities are limitless. As our search for life intensifies, so does our technology. The James Webb Space Telescope is opening a new frontier, offering unparalleled sensitivity and the ability to analyze exoplanet atmospheres with unprecedented precision. But we're also relying on other technologies like advanced radio telescopes, which can listen for potential signals from intelligent civilizations. The search for life may take many forms. While Webb and other instruments search for biosignatures, scientists are also exploring the possibility of finding signs of advanced civilizations. Could we one day detect a signal from an alien civilization? Perhaps it won't be a planet that harbors microbes, but a thriving society capable of sending us messages across the stars. As we stand on the precipice of discovery, the question still lingers. Could life exist on an exoplanet? The truth is, we don't know yet. But with each new breakthrough, each new planet discovered, we are one step closer to finding the answer. Whether life exists on another world or not, the search for it has already taught us something profound, that the universe is far more diverse, complex, and wondrous than we could have ever imagined. And as we continue to look to the stars, we may one day find that we are not alone in the cosmos, that life, perhaps in forms we can't yet comprehend, exists somewhere out there. Until then, the journey of exploration continues,